My name is Akhilay Kumar. Today I am going to present on the topic containerization, Docker and Kubernetes as a part of the cloud computing course. So in this presentation, I am going to explain what containerization is, how the Docker works, and how Kubernetes helps manage containerized applications in modern cloud environments. So let's get started. This is the introduction. So modern software application requires fast deployment, scalability, and efficient use of the resources. However, traditional deployment methods often face problems such as dependency conflicts and environmental inconsistencies. For example, suppose an application may work on a developer's machine, but it may fail when deployed on another person's system. So, to solve these problems, the term containerization was introduced. So containerization packages an application together with all its dependencies so that it can run consistently on any system. Technologies such as Docker and Kubernetes have become essential tools for building and managing containerized applications in modern cloud environments. Next is we'll talk about containerization. So containerization is an operating system level virtualization technology that allows application to run in isolated environments called the containers. So each of the container will include everything needed to run an application. So the components of a container are the application code, then the runtime environment, system libraries, and all the dependencies required to run the application. Unlike virtual machines, containers share the host operating system kernel, but they still remain isolated from each other. Because of this isolation, the same container can run consistently across developing, testing, and production environment without compatibility issues. So next one is the working of the container, how a container works. So containers work using several technologies from the Linux kernel. The first is namespace. Namespaces provide isolation for processes, networking, and file systems so that each container behaves like an independent system. The second one is control groups, also called C groups. These are used to control how much CPU, memory, and storage a container can use. The third one is union file systems. This allows containers to use layered file systems, which helps reduce duplication and save storage space. Together, all these mechanisms allows containers to function like separate systems, even though they share the same operating system kernel. Next is the comparison between the containers and the virtual machines. Containers use operating system level virtualization, while virtual machines use hardware level virtualization. Container shares the host operating system, while virtual machines require a separate operating system for each instance. Another difference is startup time. Containers start in seconds, whereas the virtual machines may take several minutes. Then containers also consume fewer resources, which makes them more lightweight and efficient. Because of these advantages, containers are widely used in modern cloud computing systems. Next one is the advantages of containerization. So containerization provides several important advantages. The first one is the portability. That means applications can run consistently across different environments such as development, testing, and production. Second one is efficiency. Containers consume fewer system resources compared to virtual machines. Third is scalability. Containers can stop or start quickly, allowing system to handle changes in workload efficiency. Fourth is the isolation. Each application run independently without interfering with other application on the same system. So these are the advantages of containerization. These advantages make containerization very useful for modern cloud-based applications. Now let's talk about Docker. So as we all know, Docker is one of the most widely used platform for containerization. So Docker is an open source platform used to build, package and run containerized applications. Developers can package their applications and dependencies into the Docker images. These images can be deployed and executed anywhere, including cloud environments. Docker simplifies the process of application deployment and also support modern DevOps practices and CI/CD workflows. So next slide, we will be talking about the architecture of the Docker. Docker architecture. So the Docker architecture consists of three main components. The first component is the Docker client. So Docker client, this is the interface through which user interact with the Docker using commands. The second component is the Docker daemon. This is the core service that builds Docker images and runs the container. And the third component of Docker is Docker registry. This is a repository where Docker images are stored. A common example is Docker Hub, which allows user to store and share the images. Together, all these components will allow the developers to build, store, and run containerized applications efficiently. Next, Docker images and containers. In Docker, two important concepts are there: Docker images and Docker containers. A Docker image is a Docker image is a read-only template that contains the application code along with all the required dependencies. Whereas a Docker container is a running instance of that Docker image. So in simple terms, an image will act as a blueprint, whereas the container is the actual running application created from that blueprint. So this approach makes application deployment simple and consistent. So next one is Kubernetes. While Docker is used to create and run containers, managing a large number of containers across multiple servers is a challenging process. So this is where Kubernetes comes into play. So Kubernetes is an open source container orchestration platform. So Kubernetes is an open source container orchestration platform. It automates the deployment, scaling, management of the containerized applications. So because of these reasons, Kubernetes is widely used in large distributed systems where thousands of containers need to be managed across multiple servers. Now the Kubernetes architecture. So the Kubernetes architecture mainly consists of two components. The first is control plane, also known as the master node. The control plane includes components such as API server, scheduler, and control manager. These components manage the entire Kubernetes cluster. The first component, the second component is the worker node. So worker nodes run the actual containerized applications. So in simple terms, the control plane manages the cluster, whereas the worker node execute the workloads. Now, features of Kubernetes. Kubernetes provides several important features. The first feature is automatic scaling. It can increase or decrease the number of containers based on the workload. So what automatic scaling does is the number of containers based on workload will be increased or decreased. Okay. The second feature is self-healing, which is an important feature of Kubernetes. Suppose if a container is failing, or suppose if it's failed, Kubernetes will automatically restarts or replaces it. So first it will try to restart the container. If it doesn't work, it will replace with another node. So this property is called self-healing. The third feature is load balancing. So we know the traffic is automatically distributed across multiple containers to ensure smooth performance. So if in one container there is too much traffic, it will pass the request to some other containers. So that is basically called the load balancing. The fourth feature is service discovery. Kubernetes automatically connects services with the cluster. So these features make Kubernetes highly reliable for managing large-scale applications. So the next one is applications. Applications of containers and Kubernetes. So these containers and Kubernetes are widely used in many real-world applications. Some common applications will include this microservice services architecture, cloud native architecture, cloud native applications, machine learning model deployment, DevOps automations, Internet of Things, etc. Then many major companies such as Google, Amazon, Netflix, and Microsoft use these technologies to run their large-scale systems. So next one is conclusion. To conclude, containerization has significantly transformed modern software development. It enables lightweight, portable, and scalable deployment of application. Docker simplifies the process of creating and running containers. Kubernetes will provide powerful orchestration capabilities to manage containers at scale. So together, Docker and Kubernetes plays a critical role in modern cloud computing and distributed systems. So containerization has revolutionized modern software development and cloud computing by enabling application to run in lightweight, portable, and isolated environment. So instead of dealing with complex dependency and environmental issues, uh, developers can package application along with all required libraries and configurations into the container, which will ensure consistent performance across different systems. So the technologies like Docker make it simple to create packages and distribute containers. So Docker allows developers to build application image once and run them anywhere, which generally simplifies deployment and support modern DevOps practices such as continuous integration and continuous deployment. That is CI/CD. However, when application scale and require 100 or even thousands of containers, managing them manually will become very difficult. So this is where Kubernetes become essential. Kubernetes automates container deployment, scaling, monitoring, and recovery, making large distributed system more reliable and efficient. Another important benefit of this containerization is scalability and resilience. Kubernetes can automatically scale application on demand and replace failed containers, ensuring that services remain available even in case of system failures. Additionally, containerization plays a crucial role in modern architecture such as microservices, cloud native applications, and machine learning deployment, allowing organizations to build flexible and highly scalable systems. So because of these advantages, containers technologies are widely adopted by leading technology companies like Google, Amazon, Netflix, and Microsoft. So in summary, Docker and Kubernetes together form a powerful ecosystem that simplifies application development, improves resource efficiency, and enables scalable cloud infrastructure. As cloud computing continues to grow, the containerization and orchestration technology will remain key components of modern distributed systems and future software platforms. Thank you.